Alright, ladies and gentlemen, today we're going to be looking at the fundamental theorem of algebra, which is mostly called the FTA. So anytime you hear someone talking about the FTA, they're talking about the fundamental theorem of algebra. Alright, so what does the fundamental theorem of algebra actually mean? Okay, the FTA simply says that the degree of the polynomial is equivalent to the number of solutions. Okay, the degree of the polynomial is equivalent to the number of solutions. Alright, so what does that mean? Alright, so let's look right here. And we'll come down here and we'll actually work these out, but let's just take a quick look. Alright, look at this polynomial right here. The highest exponent is a 3, so that means that we should have 3 solutions according to the FTA. For this one right here, the highest exponent is a 9, so that means we should have 9 solutions according to the FTA. Alright, for example 3, our largest exponent is a 3, so we should have 3 solutions according to the FTA. Okay. Now, remember that sometimes roots can be used more than once, so that's when we get the multiplicity. Alright, so a distinct root can be used more than once. Okay, so if a polynomial p of x has a multiple root at r, the multiplicity of r is the number of times x minus r appears as a factor in p of x. Alright, so the x minus r, that is your binomial factor. Alright, so what this is saying is that if we had x minus 5 times x minus 5 times x minus 5, we are using that 3 times. So that would be the same thing as x minus 5 to the third. Alright, so that's how you would write the binomial factor, but if we were going to talk specifically about the root, we would say that your root is 5 with a multiplicity, that's a lot of i's in there, of how many times we used it. How many times did we use it? We used it 3 times. Okay, so basically it is simply the number of times a root is used. Alright, so then we've got roots. Now we've talked about roots for several lessons now. Alright, roots are any value of the variable that makes the equation true, also known as x-intercepts, zeros, or solutions. Alright, so the number of solutions could be different from the number of x-intercepts, depending on how it's worded. So for example, if it says distinct roots, how many distinct roots do you have? Alright, so draw that real quick and let's talk about the number of distinct roots versus the number of solutions. Sometimes they're exactly the same number, and sometimes they're a little bit different. Alright, so when it says distinct roots, that means how many x-intercepts do you actually use. So like this one right here, we have 1, 2, 3, 4 distinct roots. Because we have 4 individual x-intercepts. But some of those x-intercepts are being used more than once. Okay, so we know when it goes straight through, it's only used one time. When it's squiggly, it's used at least 3 times. When it's a bounce, it's used at least 2 times. And here we got another squiggly, so that's used at least 3 times. So what would be the total solutions here? 1 plus 3 plus 2 plus 3. So that would be 9. So here that would be 9 solutions with 4 distinct roots. So sometimes the distinct roots and the solutions would be the same, but sometimes depending on if you got squigglies and bouncing going on, then they might be different. Okay. All right, so I gave you a general definition of the fundamental theorem of algebra, or FTA, but here is the formal definition. It says every polynomial degree greater than 1 has at least one zero. So it's saying if your degree is greater than or equal to 1, you have at least one solution, where 0 may be a complex number. All right, so we're going to get into this complex numbers in the next lesson or so. All right, the corollary says every polynomial function of degree n is greater than 1 has exactly n zeros, including multiplicities and imaginary roots. All right, so that's that imaginary, that's your I stuff. All right, so we've got a couple of steps to solve. Okay, you're going to set the function equal to 0, so that means you've got to put it in standard form, from the biggest exponent to the smallest. And then you're going to factor. Okay, you want to factor everything you can. And then you're going to take your factors and set equal to 0. And this is known as the zero product property, 0 pp. You should have done this in Math 1. After you learned to factor, you set each little binomial factor equal to 0 and you solved it. Okay. Then we could use synthetic division, or we might have to use quadratic formula for the non-factorable quadratics. And you should end up with the same number of answers as the degree of the polynomial when including multiplicities. So, as you can tell, it's mentioned factored a couple of times. So when we are working with this, we're going to have to go back to some of our Math 1 concepts and talk about factoring. All right, so looking at example 1, we see that this is in standard form. It's 3, 2, 1 constant. We see we have 4 terms. Whenever we have 4 terms, we're going to factor by grouping. Now, it is important to remember how to factor by grouping. On the release versions, the older release versions of the EOC, they've always had a factor by grouping problem. It's just like it just pops up out of nowhere. Okay, so this is a concept that we want to make sure that you understand. Okay, so to factor by grouping. Now, it's called factor by grouping. So we're going to do some grouping. We're going to group things together. What you're going to do is you're going to group the first 2 together, and you're going to group the last 2 terms together. All right, then from each group, we're going to pull out the GCF, the greatest common factor. So in this first group, what's the biggest number that goes into 8 and 4? And that would be a 4. So we're going to pull out a 4. Do they have a variable in common? Yes, they do. They have an x. So when they have a variable in common, you pull out the smallest exponent. So 2 is the smallest exponent, so we're going to pull out a 4x squared. And what happens is when you pull the factor out, you're dividing. So we're going to divide each term by 4x squared. 8 divided by 4 is 2. If we had 3 x's, but we're taking 2 out, we're left with 1. So we get 2x. Anything divided by itself was 1, so we got minus 1. So let that sink in for a second, what we just did. We grouped the first 2 terms and then the last 2 terms together. We looked at that first group and we saw they had a 4x squared in common, so we divided out that 4x squared. Alright, for this second group, we got a 50 and a 25. Well, they have a 25 in common, and anytime there's a negative right there, well, I shouldn't say anytime, majority of the time, you always want to pull out that negative. So we're going to pull out a negative 25. So we're going to divide both terms by a negative 25. Negative 50 by negative 25 is a positive 2. Bring down the x. Positive 25 divided by negative 25 is a negative 1. Now, as you're copying this down, what do you notice about the parentheses? They are exactly the same. When your parentheses end up being exactly the same, you know this is correct. So we're going to come right here. You're going to take these outside terms and you're going to group them together. So we get 4x squared minus 25. And then we're going to group our parentheses together. 2x minus 1. And that p of x, that's the same thing as 0. So we're going to set that equal to 0. Now, just to make sure before I solve these that I have done this correctly, I'm going to verify using Desmos. Alright, so for the time being, we weren't trying to solve, we were just trying to change it from one form to another form. We're trying to change it from standard form back to a factored form. So let's see if we get the same graph. That lets me know if I've factored it correctly. I've got 8x cubed minus 4x squared I'm struggling here. It's on the struggle bus. Squared minus 50 minus 50x plus 25. Okay. All right, then I'm going to come right here, line 2, I'm going to put my parentheses, 4x squared minus 25 times 2x Lord have mercy. I'm struggling, y'all. 2x minus 1. Alright. Do we see the same graph? Yes. So that lets me know that is the correct factored form of it. Okay, so that's a great way to verify your answer. So on a test or a quiz, if I said, hey, factor this, and by grouping, and you know you got 4 terms, you put that in line 1, you put your answer choices in line 2 to see which ones give you the same graph. Okay. Alright, but here they're actually asking us to solve. So in order to solve, okay, we have, it's already set it equal to 0, we have factored everything, so now we're going to use the zero product property. And what that does is take each factor and set it equal to 0. So I'm going to come right here, and I'm going to say 4x squared minus 25 equals 0. And then I'm going to take this one and say 2x minus 1 equals 0. And we're going to solve those. Alright. The opposite of subtracting 25 is adding 25. So we get 4x squared equals 25. The opposite of multiplying by 4 is dividing by 4. So we get x squared equals 25 over 4. But that is x squared. So how do I solve for x squared? Well, the inverse is square and something is taking the square root. So here I'm going to end up with x equals, the square root of 25 is 5, square root of 4 is 2, And since it's the square root, it is the positive and the negative version. Alright, for this equation, I'm going to add 1 to both sides. So I get 2x equals 1, and then I'm going to divide by 2, and I get x equals 1/2. Now, how many solutions do you see right here? Alright, I see a positive, a negative, so that's 2, and then I see a 1/2, so that's 3 solutions. Let's see if we have found all of our solutions. What is the degree of this function? Alright, the biggest exponent is 3, so the degree is 3, which means I should have 3 solutions. Okay, so again, according to the FTA, there should be 3 solutions. And I do have 3 solutions, so I know I've solved this correctly. Alright, another way I can see the answer very quickly. Alright, we know that x-intercepts are also called solutions. So coming right here, I can look at my x-intercepts. 5/2 is the same thing as 2.5, so I got a negative 2.5 and a positive 2.5. 1/2 is the same thing as 0.5, and I got a 0.5 right there. I know you think, oh, Miss CP, why didn't you just show me this to start with? Because I need to show you how to factor by grouping. Alright, for example 2, it says solve for all solutions. Well, we're not going to solve this one because it takes quite a bit to solve this one. And so I'm just going to look at it and we're going to determine how many solutions we should have. So what is the degree of this function? What is your biggest exponent? Well, the biggest exponent is 9. So according to the FTA, we should have 9 solutions. And if you're really just dying to know how to do that one, I worked it out right here. It's a doozy. Alright. Alright, so what I've done for example 1 is I've shown you the long way. Okay, so we factored it, we found our solutions by using zero product property. Well, remember how we did synthetic division? Okay, we're getting ready to really use synthetic division here. So you're going to really enjoy this now. Alright, so look right here for this one. Alright, let's pick out our degree. Alright, so here our degree is 3. So that means we should have 3 solutions. Well, they've done something really, really nice for us. They have told us that x equals 6 is a root. So since x equals 6 is a root, we can come right here and we can use synthetic division starting with 6. Alright, so my root is 6. Alright, 3, 2, 1 constants. I've got all my terms. They're in descending order. There's no missing term, so we don't have to do a placeholder. So here we've got a 6, a negative 29, a negative 45, and an 18. Oops, I didn't mean to put plus there, but it's a positive 18. Alright, we know we're going to drop the 6. 6 times 6 is a positive 36. Combining these, 36 minus 29 is 7. 6 times 7 is a positive 42. Combining these, negative 45 plus 42 is a negative 3. 6 times negative 3 is negative 18. Combining these, we get a 0. If this is a root, you should always get a 0 here. If you don't get a 0 right there, then you've messed up on your sign somewhere. Alright, so what we have here, this was originally an x cubed. But now, each time we do a synthetic division, it drops a degree. So this is x squared, a positive 7x, and a minus 3 equals 0. Now that we've got it down to a quadratic trinomial, we can use quadratic formula. So we're going to come right here, we're going to pick out our A, our B, and our C. Our A is 6, our B is 7, and our C is -3. Alright, so let's see, we got negative B plus or minus the square root of b squared minus 4ac all over 2a. Alright, so B is 7, A is 6, and C is -3. Alright, so again, just for those of you who might have forgot the formula, negative B plus or minus square root b squared minus 4ac all over 2a. Alright, so the opposite of 7 is -7. 2 times 6 is 12. And let's find out what the discriminant is going to be. Alright, 7 squared is 49. 4 times 3 is 24, and 24 times 3 is 72. And negative times negative gives us a positive, so we're adding these together. 49 plus 72 is 121. Oh, that makes it nice. 121 is a perfect square. The square root of 121 is 11. So we have -7 plus or minus 11 onto the square root of 12. Alright, so let's find these answers. We've got a -7 plus 11 over 12. And then we have a -7 minus 11 over 12. And remember, we got the plus and the minus, so that's why we set up two little expressions here. Alright, so 11 minus 7 is 4. And 4 over 12 reduces to 1/3. -7 minus 11 gives us a -18 over 12. And reducing that by 6, we get -3 over 2. Alright, we're supposed to have 3 solutions, so do we have 3 solutions? Yes, we do. We got -3 halves, positive 1/3, and then the root they already gave us 6. So our 3 solutions is a -3 halves, a 1/3, and then 6. So that's all 3 of our solutions. Alright, if you need to pause this to finish copying it, go ahead and do that now. So I'm going to go ahead and move to our next set of examples. Alright, writing equations from graphs or given information using FTA. Alright, so our steps here are to pick out the roots or x-intercepts, write in factor form. And remember, factor form is x minus your root. Then we'll multiply in binomials using the FOIL or matrix box method, use the distributive property, and then simplify. Alright, so what are the roots to this first one right here? Well, the roots are 0 and 4. So we've picked out the roots. Now we're going to write in factor form. So we're going to write here and say x minus 0 times x minus our root of 4. That is factor form. Now, normally we wouldn't see x minus 0, would we? We would just see x times x minus 4. Alright, so it says multiply the binomials. Well, we don't have two binomials. We have a monomial and a binomial, so we're going to use the distributive property. So x times x gives us x squared, and x times -4 is -4x. That is our standard form. Okay, so f of x equals x squared minus 4x. So for these, you always pick out the root, write it in factor form, and then change it to standard form. Now, let's verify and make sure this is correct. Now, you can verify because you're trying to change it from one form to another form. So we got x minus 0 times x minus 4. That's factor form. And now let's choose our standard form. X squared minus 4x. All right, do we see different graphs or do we see the same graph? We see the same graph, so we know that these two are equivalent. So we know that our standard form is right. All right, what kind of function is this? Do you remember? It's the parabola, so it is a quadratic. And since it is a quadratic, notice the direction it's going. It's opening down. Now, I know some of you are probably itching to say, oh, Miss CP, you're wrong about something, you forgot something. But no, I was just saving it to the end. Since it's opening down, I know I should actually have a negative. So up here, I would have put a -1 for my a value. And then right here, what's going to happen is that once we apply that -1, it's going to change the signs right here. Okay, so that would really be, if I multiply this by that -1, -1 times x squared is -x squared, and negative times negative is a positive, so we get positive 4x. And the dead giveaway should have been when we verified it. Notice this parabola is opening up, but this one is opening down. So that told us that we had done something wrong. So if I just come right here and put a -1 in front, and then right here, I'm going to do -1. Let's try it again. -1, parentheses. So now it matches. 0 and 4 opening down. Alright, so just to see who's paying attention, right here, under this right here, I want you to write the word apple. Write the word apple. Alright, in example 5, we have that W shape. And remember that W shape is a quartic. Since it's a quartic, that means that we have a degree of 4, so we should have 4 solutions. Alright, so I see a -2, I see a -1, I see a 1, and I see a 2. Alright, so since these are x-intercepts and they're whole numbers, I already know what the solutions are going to be. The solutions would be -2, -1, 1, 2, but we want to write the equation. So we're going to put it in factor form. And notice this is opening up, so it would be positive. Okay, so we're going to say x minus 2. I'm going to put the values side by side that match. And then I got another 2, so that's a positive 2. Let's try this again. X minus a -2 would actually give us positive 2. And this 2 right here in the equation would give us a -2. Then for our 1s, this would give us x plus 1 and x minus 1. Alright, so that's factored form. If you can write it in factor form, and they want you to put it in standard form and it's multiple choice, as long as you can do this, you can figure out what your standard form is. Because again, you could put that in line 1, and we're trying to change it to a different form, so you'd put your answer choices in line 2 and see which ones give you the same graph. Alright, but right here, what I'm going to do is we're going to come right here, we're going to multiply this. Okay, so we're going to multiply these two together and these two together. That's that step where we're going to FOIL it, and then we're going to use our distributive property. Alright, so x times x is x squared. Outside terms, -2 times x is -2x. Inside terms is 2 times x. And then when we combine them, 2 minus 2 is 0, so our middle terms of x's actually cancel out. 2 times -2 is a -4. Alright, this one right here, x times x is x squared. Alright, outside terms of x times -1 is -1x. 1 times x, our middle terms, is a positive 1x. So again, 1 minus 1, they cancel out, so we're left with just the first term and the last term. 1 times negative 1 is negative 1. Now what we have right here is the DOS, difference of squares. And we always know that we're going to have difference of squares when your two binomials are exactly the same, but one's a positive and one's a negative. Alright, so we have multiply using FOIL, so now we're going to distribute. Alright, so we're going to take this x squared multiply times everything right here. So x squared times x squared is x to the 4th. X squared times negative 1 is negative x squared. Alright, we're going to take this negative 4 and multiply everything times right here. Negative 4 times x squared is negative 4x squared. And negative 4 times negative 1 is a positive 4. So x to the 4th, negative 5x squared plus 4. That is our standard form. And I know you're thinking, oh my gosh, that's a lot. So like I said, if you can put it in factor form, you can figure out what the answer, you should be able to verify what the answer is. So let's put this in factor form. Alright, so we have x minus 2 times x plus 2 times x minus 1 times x plus 1. Alright, and then let's check to see if this is correct, because I could have made a mistake. Alright, so we got x to the 4th minus 5x squared plus 4. Alright, do I see a different graph, or are they the same? They are the same, so that lets me know that these are going to be equivalent, so that's my right answer. Alright, so here in example 6, I just want you to write this in factor form. Okay, so we did 4 and 5 in standard form, but for example 6, we're just going to write it in factor form. We're going to review a little bit about multiplicity. Alright, so right here at negative 5, notice we have a bounce. We know a bounce is used at least twice. So here we would say negative 5 with a multiplicity of 2. Right here at negative 1, this goes straight through. Alright, when it goes straight through, it's only used once. So we would say negative 1 with a multiplicity of 1. Right, and then right here, we have another bounce at 2. So that would be 2 with a multiplicity of 2. So the minimum degree, let's see, we got 2 plus 1 plus 2 would be 5. So we should have 5 solutions, but we only have 3 distinct roots. We have 3 x-intercepts, but some of those are being used more than once. Okay. So now let's write this in factor form. Alright, let me write twice right here. When we have a bounce, we know it's used at least twice. Alright, so factor form, we're going to have p of x equals. Alright, negative 5 would be x plus 5. It has a multiplicity of 2, so that means it's being used twice. Alright, negative 1, so that would be x plus 1. It has a multiplicity of 1, so it's only being used once. And you can put a 1 there if you want to, but you don't have to. And then we got a 2, so that would be x minus 2 with a multiplicity of 2, so the exponent would be 2. So this is what your factor form would look like. Now, it's a quintic because it has a degree of 5. If for some reason they asked you to change it to standard form, you would just multiply everything out and distribute it. But I'm not going to ask you to do that. Alright, so with that being said, let's let number 7 be a you try. write it in factored form for me. So pause this for about 3 minutes and write it in factor form. Alright, so let's see how you did. Alright, this is a straight through, so that's used once. This is a straight through, so that's used once. Straight through, so the 0 is used once. Straight through, so 1 is used once. And 2 is only used once. So this makes this one pretty easy. So we're going to have P of x equals. Alright, let's go from left to right. So we had a negative 2 first, so that's going to be x plus 2 times x plus 1 times x minus 0 times x minus 1 times x minus 2. Alright, so that's factor form. But as we said in an earlier problem, we usually don't see x minus 0. So the way that we would really write this, you would see x times x plus 2 times x plus 1 times x minus 1 times x minus 2. So whenever you see an x by itself, remember that has a root of 0. They just don't put the minus 0. Okay, so again, root of 0. Now, at any time that you need to finish copying something, remember you're at control of this. You can pause the video. For example 8, they're telling us to use Desmos to verify. So we want to write an equation in standard form given the roots, assuming a minimum or least degree. That just says that it's used the smallest amount of times. Alright, so here we're not listed anything with any multiplicities. We say we have a degree of 3, so that means we should have 3 solutions. So we got 1, 2, 3 solutions. So we'll come right here and write it in factor form. Alright, so we've got x minus 4 times x plus 5 times x minus 2. So in Desmos, you would put that in line 1. Now let's change this to standard form. If you notice, you got 3 binomial factors. Well, FOIL uses only 2 at a time. So I'm going to multiply these 2 first and then multiply that with a distributive. So I'm going to go ahead and bring this down. And I'm going to actually write out every step here. Alright, so FOIL, x times x is x squared. X times negative 2 is negative 2x. 5 times x is 5x. And 5 times negative 2 is negative 10. I see I've got some like terms right here I can combine, so let's combine those. That's going to give me x minus 4 times x squared. 5 minus 2 is 3. And then minus 10. So we have put it in factor form. We had used FOIL, and now we're going to use the distributive property. For the distributive property, it says take what's on the outside and multiply it times everything on the inside. So let's start with this x here. X times x squared is going to give us x cubed. X times 3x is going to give us a positive 3x squared. X times negative 10 is going to give us a negative 10x. Alright, we're done with the x, so now let's go through and multiply everything by negative 4. Negative 4 times x squared is negative 4x squared. So I'm going to put my x squareds under each other. Negative 4 times 3x is going to give us a negative 12x. And negative 4 times negative 10 is going to give us a positive 40. So let's combine like terms. So p of x is going to equal, bringing down the x cubed, so there's no other x cubed. 3 minus 4 is negative 1. Negative 10 minus 12 is negative 22. There's no other constant, so let's bring that down. So here is my standard form. Now we would put this in line 2 in Desmos, and they should give us the same graph if we have done this correctly. Alright, so verify with me. Don't just sit there like a stump on a log. and just watch me do this. Alright, so let's put in our factor form first. We've got x minus 4 times x plus 5 times x minus 2 right? And then we've got x cubed, oops, try that again, x cubed minus x squared minus 22x plus 40. Oops, I put a y there, didn't I? Oh, I forgot my x squared right there. That's like something ain't right there. Alright, so if you notice, no matter which equation we select, it's the same graph. So let's say that choice A gave you this right there. We would know choice A was not the right answer. Let's say choice B gave us that right there. That would let us know that choice B is not the right answer. So let's say choice C gave us this graph right here. That would tell us that choice C is the graph. Alright, we're going to let number 9 be a U try. So pause the video, and it's just like number 8, so give it a try. Alright, so remember where it says minimum or least degree? That just means the lowest degree. So remember, straight through is used once. If it's a bounce, it could be used 2, 4, 6, etc. times, but the smallest number it could be is a 2. If it's a squiggly, it could be used 3, 5, 7, etc. The smallest number of times that could be used with a squiggly is a 3. So that's what it means by the minimum number, the minimum degree. So writing this in factor form, we're going to get x plus 1 times x minus 3 times x minus 2. Alright, so that is factor form. Alright, I'm going to multiply these two right here together. X times x is x squared. Negative 3 times x is negative 3x. X times negative 2 is negative 2x. And negative 3 times negative 2 is a positive 6. When I combine like terms, I'm going to get x squared minus 5x plus 6. So using my distributive property, x times all of this. So let's see, we get x cubed, negative 5x squared, and then plus 6x. Multiplying everything by 1, we get x squared minus 5x plus 6. Combining our like terms, so we get p of x equals x cubed, negative 5 plus x would be negative 4x squared. 6 minus 5 would be 1x, and then bring down the constant of 6. So again, the way that you would check this, you would, oh, this is standard form. Let me put that down. You would put this in line 1. You would put this in line 2. And if you have done this correctly and they're equivalent, they would be the same graph. Alright, just 2 more examples and we'll be done. Woohoo! Alright, so in example 10, they're going to give us a multiplicity problem. Alright, so right above example 10, right here above example 10, I want you to write the word Pop-Tart. That's going to let me know who's paying attention and who's not. Okay. Alright, so I just want to write this in factor form. Okay, so I'm going to change these directions to factor form. And the same thing with this one right here. We're going to write these two in factor form. Alright, so we're going to have P of X equals 2 with a multiplicity of 3. That multiplicity means that the 3 is going to be your exponent. So here we would have x minus 2 with an exponent of 3. Okay. Then we have a negative 5, so we got x plus 5. Now it's telling us that the degree is 4. So how many times did I use this? I used this one 3 times. How many times did I use this one? I used that one 1 time. And 3 plus 1 does give us 4. So this is our answer in factored form. Now, if you really wanted to challenge yourself, you could come right here and say x minus 2 times x minus 2 times x minus 2 times x plus 5. Multiply these two together and get that trinomial. Multiply these two together and get that trinomial. And then distribute everything. And once you did that, if you were to write it in standard form, you would get P of X equals x to the 4th minus x cubed minus 18x squared plus 52x minus 40. That one's fun. I really do like that one, but yeah. All right, and then our last one. Okay, this time we're given a table, a frequency table. Okay, so we want to write a polynomial with a 7th degree. That means our biggest exponent would be 7 if we multiplied everything out. But here I'm just going to have us write it in factor form. Alright, so let's look at this right here. Remember, multiplicity is simply telling you how many times that's being used. So that's, oops, not degree, that's giving us the exponent to write for the binomial factor. So right here we would have P of X equals, alright, we got a 0, 3, so x minus 3, but it's used twice, so the exponent would be 2. Alright, we got a negative 2, so that's going to be x plus 2. We have a multiplicity of 1, so that's only used once. Now we don't have to put that 1 there, but just for demonstration purposes, I am going to put it there. Our next root is a 5, so that would be x minus 5, multiplicity of 3, so that has an exponent of 3. And then negative 7, so we got x plus 7 with a multiplicity of 1. And this is what your factored form would look like. Alright, so make sure your name and date are on the notes and submit those notes for me, please.